Hello again, everybody. Welcome back to the Majestic Masiakasaurus YouTube channel. It's great to have you. Sorry it's been quite a while, but doing this while also applying for college and still being a senior in high school is quite a bit of work. Anyway, as you might know if you've seen any of my earlier videos, I'm a bit of a dinosaur and paleontology nerd. So on that topic, I recently found a video on the YouTube channel called Answers in Genesis, claiming to have evidence against the theory that dinosaurs are the ancestors of modern birds. Well, it wasn't exactly something I could just pass up, so we're going to take a look at that video today and I'll stop a few times along the way and add my own thoughts. Let's get started.
Did dinosaurs evolve into birds? That's certainly widely believed today.
First off, I'd like to mention that Dr. Menton is not a paleontologist, not an evolutionary biologist, not even a wildlife biologist or zoologist. He is a cell biologist, so the topic of this video is a bit outside his field of expertise. And though I certainly don't have a PhD or any college degree yet, this sort of is my field of expertise. So, as is always a good idea when evaluating opposing sides to any argument or point of view, I encourage you to form your opinions based on the most compelling evidence and reasoning, not on who happens to be promoting said evidence or reasoning.
In fact, most evolutionists now classify the birds under the Dinosauria. So you might say birds aren't extinct, or dinosaurs aren't extinct. They're feeding from our bird feeders even as we speak here.
That is correct. We actually classify birds as avian dinosaurs. So while non-avian dinosaurs have been extinct for around 65.5 million years, you probably see dinosaurs every day. How cool is that?
Not all evolutionists are in agreement that dinosaurs evolved into birds.
Well, it would be pretty difficult to find anything that every single scientist on the planet is in agreement about, though I think you'd get pretty dang close with the theory of evolution. If you're a biologist of any kind, which Dr. Menton apparently is, you'll almost certainly agree that Darwinian evolution by natural selection has become a crucial foundation to all fields of modern biology. The word evolutionist is now essentially synonymous with biologist, and it's sort of a non-expression at this point. However, with a sample size large enough, you will always have outliers, which Dr. Menton is making clear.
Alan Fiducia, for example, who's a very well-known evolutionist, believes that birds are ultimately related to reptiles, but he's not inclined to believe a lot of the current ideas of dinosaurs evolving into birds.
To clear this up, Alan Fiducia is probably the most well-known proponent of the idea that birds are not descendants of the non-avian dinosaurs. However, referencing Fiducia here does not actually help Dr. Menton's case, as he, judging by his connection to Answers in Genesis, probably does not believe in evolution, period, whilst Fiducia believes that birds' ancestors are of a more ancient lineage of reptiles. He's held this belief for decades now, ever since the dinosaur-bird connection was just beginning to hold some credibility. However, the massive amounts of fossil evidence discovered recently has left Fiducia among a tiny handful of supporters. That's not to say that I'm right because more people will agree with me, as that's completely fallacious, but we'll get to some actual evidence shortly.
There are several problems with this matter of dinosaurs evolving into birds. First, let's look at it from the Christian point of view. The Bible makes it pretty clear.
Alright, I'm literally going to skip this entire section because I don't really care what the Bible has to say on the matter. The Bible has some good stuff to say, and it also has some truly awful stuff to say, but most importantly, it's not a scientific authority. So, for the sake of time, let's focus on the scientific point of view.
From a scientific point of view, I think the evidence is not compelling that birds came from dinosaurs. There's several reasons for this. First of all, of course, dinosaurs are reptiles, although you might wonder whether that's even considered to be true nowadays.
No, they're still reptiles.
Many evolutionists prefer to think of dinosaurs as warm-blooded creatures. There's no compelling evidence that they were warm-blooded.
False. There is quite a bit of good evidence to suggest that dinosaurs were warm-blooded, or at least some kind of in-between-bloodedness. Let me just give you a few examples. Some of the earliest ideas for warm-bloodedness in dinosaurs were propagated back in the 1960s at the initiation of what is commonly referred to as the dinosaur revolution. One of the main discoveries to fuel this revolution was John Ostrom's Deinonychus, a larger relative of the more famous Velociraptor. Just a quick look at this creature was enough to be sure it was a quick, deadly, and active hunter with a high metabolism, a key feature of the endotherms, or warm-blooded animals. It was nothing like the giant, sluggish, cold-blooded lizards dinosaurs had previously been assumed to be. One of Ostrom's students, Robert Baker, later conducted an experiment where he counted the number of known carnivorous dinosaur species compared to the number of known herbivorous ones. Endothermic, or warm-blooded, predators such as lions need a lot of food to support their high metabolism. So they make up the minority of species in an ecosystem as to preserve the balance between predators and prey. In contrast, ectotherms, cold-blooded predators such as crocodiles or snakes, can eat a big meal maybe a few times a month and be satisfied. Surprisingly, or perhaps not so surprisingly, predator dinosaurs made up only a sliver of the dinosaurian species pie, much like how warm-blooded mammalian ecosystems are set up today. This is very different from how the predator-prey ratio was set up in the Permian period, the age right before that of dinosaurs, in which all of the dominant species were cold-blooded, and predators made up over half of the species pie. A more recent set of studies have focused on the microscopic level. Just like trees, bones too lay down growth rings. And while you probably know that the number of rings correspond to the years of life, the space between rings can also indicate the rates of growth. So, some recent studies have literally cut transsections of dinosaur species bones to take a look at their growth rings. Turns out, it seems like dinosaurs grew faster than typical reptiles, again indicating a possibility for warm-bloodedness, or at very least some sort of in-between-bloodedness. Okay, I realize that was quite a bit of information on a bit of a minor point, and the question is somewhat still disputed. However, it seems clear that dinosaurs were probably at least mesotherms, somewhere in between the spectrum between totally hot and totally cold-blooded. You'll see that throughout the video, Dr. Menton will just assert that there isn't much evidence. So, I'm going to respond by giving you a lot of evidence.
But some of the major differences between birds and dinosaurs are not in the bones, but in the soft tissue of the body, which of course is usually not preserved. For example, the reptile lung is quite different from the bird lung. Birds have a lung which, as far as we know, is not found in any other creature. It's a kind of a through-flow ventilation system where the air goes in through the trachea, but then exits from several positions in the lung to go out into air bags that are under the skin and sandwiched between the muscles. We see nothing like this in reptiles.
Carcharodontosaurus has a hidden advantage. In 2008, detailed bone analysis suggested these dinosaurs employed a system of air sacs. Air sacs are used in breathing. They ensure that oxygen-rich air flows continually through the lungs when breathing in and out. It's a very efficient system, similar to that of birds.
Also, sure, we might not see anything like this in modern-day reptiles, but it's not like we're proposing a link between birds and living species of lizard or something. We need to find evidence of extinct dinosaur lungs. Of course, this is hard to do because, as Dr. Menton correctly pointed out, soft tissues like that of a lung don't really ever fossilize. However, like that clip from the 2015 show Planet Dinosaur alluded to, we don't necessarily need to see the lungs or the air sacs themselves to think that they might still have been there. Because of the unique way a bird's system of lungs and air sacs can interact with the surrounding bones, moving around and sometimes even through special openings in the bones, we can compare the ribs, sternum, vertebrae, and other related bones in birds to the theropod dinosaurs, that is, the group that would eventually give rise to birds. And guess what? People have done this. One example compared a modern crane to the extinct Majungathalus atopus. Surprisingly, or perhaps not so surprisingly, a lot of the bones looked pretty similar.
Recently, fossils were found of a dinosaur in which the soft tissue of the lung was reasonably well preserved, not as soft tissue, but of course mineralized. This appeared to be very much like an alligator lung, not like a bird lung. So the respiration is quite different, and to turn a reptile into a bird would require a really radical difference in the whole respiratory system.
To be honest, I'm not totally sure what discovery he's talking about here. I hunted around for a bit trying to find anything like it, and the closest thing I got was the preserved lung of a small proto-bird called Archaeorhynchus spathula, who shared many traits both with modern birds and with the ancient small two-legged dinosaurs, and whose respiratory system was quite similar to that of birds. Also, Dr. Menton asserts that the transition between a reptile to a bird lung would require a drastic change. However, a crocodile lung, for example, does share some important characteristics with both that of birds and dinosaurs. Unlike our mammalian lungs, air moving through a crocodile or a bird lung moves in a one-way loop. This is called a unidirectional airflow system. Though crocodiles don't share the complicated system of air sacs that birds use, it's actually not that difficult to imagine how some ancient reptile with a respiratory system to that of a crocodile could, given millions of years, give rise to the incredibly efficient system employed by all dinosaurs, including birds.
There are other differences as well. Both dinosaurs and birds, at least most of them, have 3 fingers. That seems to look similar, except that it's been shown that in the case of the dinosaurs, the 3 fingers correspond to finger 1, 2, and 3. That would be the thumb, forefinger, and next finger. In the case of birds, the fingers correspond to fingers 2, 3, and 4. So almost all vertebrates that walk on 4 limbs or fly develop in the embryo with 5 fingers, but here we see the 5 fingers being reduced to 3, and different fingers are used in the dinosaur and the bird, which would suggest they're not related.
First of all, even if this digit dilemma did pose a serious threat to the hypothesized direct connection between birds and dinosaurs, it would absolutely not suggest they were not related, as every living organism is ultimately related somehow if you go back far enough. Think of it this way. If you trace your ancestors back all the way, like 3.5 billion years, you'd find there only be one species of life on Earth, the first life form on the planet. This is known as Luca, or the last universal common ancestor, because this creature, whatever it looked like, would give rise to all of the extinct and modern living species of animal. Anyway, let's get back to the digit dilemma. By the way, I'm just warning you, this part does get a bit technical and it's kind of a long tangent. I really try to make it understandable and I think it's super interesting, but if you really like to skip it, you can jump to this timestamp here. In 2009, a group of paleontologists led by the famous paleontologist Zhu Xing, along with James M. Clark from George Washington University, who I was fortunate enough to correspond with a bit while researching this topic, described a new primitive species of theropod dinosaur called Limusaurus inextricabilis. Limusaurus was an interesting find for a number of reasons. It was an Asian herbivorous ceratosaur from the Jurassic period, if that means anything to you. But it also had a very small residual first finger, the dominant being 2, 3, and 4, like that of modern birds. This find was a key piece in formulating a new theory about the apparent digit contradiction and showing that things aren't quite as they seem. It's important to understand that the data we have for assuming that extinct theropods exhibited digits 1, 2, and 3 is based on fossils and what each finger looked like, because each finger has a slightly different morphology.
The form and structure of an organism or any of its parts, like fingers.
Whereas birds seem to exhibit digits 2, 3, and 4 because we can look at which digits are forming when a baby bird is still in the embryo, when the digits are not yet fused together into a wing, but are still separate, so we can see which they are. Then, if you realize that Limusaurus, a dinosaur pretty early on in theropod evolution, has a reduced first finger, with the primary digits being 2, 3, and 4, you might start putting the pieces together. The theory is that early on in theropod evolution, there was a frame shift in digital identity, and Limusaurus is an intermediate phase. All that jargon means is that over time, as digit 1 is reduced, digits 2, 3, and 4 grow to take on the morphology, the shape, the identity of digits 1, 2, and 3. That just means that when we find fossil hands of later theropods that are more closely related to birds, and they look like they have digits 1, 2, and 3, they're actually still digits 2, 3, and 4, they just look like 1, 2, and 3. Okay, I know this stuff is pretty complicated, and I don't understand every last detail myself, but at least I did some research to try to look at the evidence and get a gist for what's going on. Dr. Menton, on the other hand, is committing a huge argument from ignorance fallacy, which, well, I'm going to leave you hanging for just a bit because, spoiler alert, he's about to do it again right now.
I think my most compelling evidence that dinosaurs did not evolve into birds is the whole problem of turning a reptile scale into a feather.
Huh, that's interesting, because I think that the feathers provide some of the most compelling evidence to suggest birds did evolve from dinosaurs.
These are very different biological structures. Even though both are appendages of the skin and both contain keratins, they are developmentally and every other way very different. A scale is sort of like a fold in the skin, and several scales are one fold after another. That's why scales are shed as a sheet from reptiles. But feathers are shed in matched pairs in the case of birds. Birds do not shed their whole skin the way reptiles do. So that developmentally the structures are different, and of course under the microscope it's hard to imagine something that differs more than the structure of a reptile scale on a feather.
Alright, so this one can get a bit complicated, again, though for time's sake and because I already spent my tangent time on the digit dilemma, I'll keep this part pretty simple. But if you are really curious about the evolution of feathers, I left a link in the description to one of the most comprehensive pages I found on the topic, though it does get a bit technical sometimes. First off, feathers probably did not actually evolve from scales, because, as Dr. Menton points out, there are significant differences between the two. Scales are flat folds, for example, while feathers are tubular structures, and the keratin they're both made of are actually slightly different. Rather, what's much more likely is that feathers are an evolutionary anomaly and evolved completely independent from scales. Again, if you want to know that exact process, link in the description. Look, we have so much fossil evidence that dinosaurs has feathers, you simply cannot deny that connection anymore.
Whether it's a layer of simple fluff for warmth, or long stiff tail feathers for display, or beautiful forearm feathers for flight, the feathered connection between these dinosaurs and birds is indisputable. Heck, we even have a feathered dinosaur tail preserved in amber.
Lastly, both Dr. Menton's arguments concerning feathers and the digit dilemma, the finger discrepancy thing, are perfect examples of an argument from ignorance fallacy. Essentially, this is to say that just because you don't understand how something works, that doesn't mean it doesn't work. Dr. Menton is not an expert in this field and doesn't appear to have taken any time to do adequate research, so he feels somehow okay to put up a public YouTube video in opposition to a theory he clearly does not understand. It's not magic, it's science. Well, that's the whole video, so we're almost done here. Though there's one more thing I'd like to mention concerning that first section I outright skipped, in which Dr. Menton examines evidence from the Bible. The fact that he started with the Bible before discussing any current scientific evidence is representative of Dr. Menton's fallacious path to understanding. To reasonably come to any scientific conclusion, we must first examine all of the available evidence and then devise our conclusion, which synthesizes that evidence into the most likely conclusion. The problem here is that Dr. Menton begins with the conclusion given to him by the Bible, which, I might gently remind you, is not exactly a scientific authority. And if you start with the conclusion that the Bible is perfect in every way and must be taken literally, then you'll find yourself making extraordinary claims that we can say with great confidence now are simply not true, such as that the Earth is only 6,000 years old, or that grass existed before any animals did. Then you can cherry-pick bits of evidence all you want that seem to support your predetermined beliefs, but that's not how science works. We have to start with our evidence and form a conclusion from there. And if said conclusion appears to be in conflict with what you thought beforehand, then, well, you might have just been wrong about that one. Which, of course, is totally fine. People, including scientists, make mistakes all the time. We just need to be able to recognize our mistakes and change our minds. Otherwise, we can't make any progress. Alright, that's all I have for y'all today, so I hope you really enjoyed the video, and if you did, please go ahead and like it and consider subscribing to the channel. I certainly had a lot of fun putting this together. Anyway, thanks again for sticking around this far, and I hope to see you in a later one. Peace out.